Okay, hi guys. So in this lecture, we'll be seeing some more examples on the isocyanate test. So let's start. So we have something like uh, aniline, and again we are reacting it in presence of chloroform and in basic medium. So what would be formed? Obviously, the isocyanate would be formed here. Okay, and what would be the mechanism? Obviously, first this will convert into CCl2 carbene. Okay, then this would be attacking on this form carbon to form something like plus here, and we have two H's attached here, and we have C minus Cl2. Okay, next what will happen is again OH minus will attack on this acidic hydrogen and will get something like this product. Okay, and H and C minus Cl2. Again what will happen is it will form double bond with the carbon atom and will get something like this, and with the positive charge on the nitrogen atom, and Cl2 minus charge on on carbon atom. Again OH minus will attack on this acidic hydrogen and will get something like this product. Okay, and will get C minus Cl2. Now what will get? Again the lone pair will form the triple bond with the carbon atom. I'm sorry, I just forgot to remove one carbon atom here. Okay, one of the chlorine from the carbon bond would actually detach itself. Okay, and will get C minus Cl, and this also will get C minus Cl. Okay, next what will happen is again, as the triple bond is forming between the nitrogen atom and the carbon atom, this Cl will actually detach itself from the carbon atom, and the bond will be formed between nitrogen atom and the carbon atom. So this is isonitrile formed. Okay, so just remember uh, the mechanism. It's a slightly a tricky mechanism. Okay, um, so I think we are good with these examples. We have seen a lot of examples for the isocyanate test. So now we'll be moving on to our next reaction, which is Kolbe-Schmidt reaction. Okay, so what is Kolbe-Schmidt reaction? We have phenol. Okay, and in this phenol we would have CO2 attached with the phenol atom, with the phenol, or CO2 in the mixture with the phenol, and we are reacting it in presence of NaOH and H plus. So what will happen is we'll get something like a benzene carboxylic acid attached with a OH group. Okay, so let's see the mechanism to understand this reaction better. So we have something like, the first step we have the phenol. Okay, which in basic medium we are providing NaOH. Okay, so in basic medium what will happen? Again this OH minus will attack on phenol, will get O minus. Okay, then this O minus will then be getting into resonance in the benzene ring and will convert itself into something like this. Okay, this compound will then attack on carbon atom from the CO2 molecule and will get something like this, O minus and double bond O. This oxygen atom will also withdraw its bond electron from the carbon atom, thereby forming a compound something like this. Okay, next what will happen is, obviously we also had a hydrogen atom here which is acidic, and we are in basic medium. So what will happen is this OH minus will attack on this hydrogen atom. As a result, it would form a pipe or double bond between this carbon atom and this carbon atom, and O minus will again be restored. Okay, so we'll have something like this. Okay, so second as we are passing it in acidic medium. I mentioned also here the second step is we are passing at acidic medium or H plus in the reaction mixture, so we'll get phenol and OH group and OH C double bond OH in the mixture as a product. Okay, so this completes the mechanism of Kolbe-Schmidt reaction. Let's see another example where we have something like, so what if okay, before going into this, what if we extend this phenol or the product formed and we react it with something like anhydride. So what will happen? This is an anhydride, so SN-AE reaction will take place, addition and then elimination, which is also called acetylation. Okay, so how will the reaction go forward? So the O minus, the OH, so the O has lone pairs, will actually attack on this carbon atom. Okay, and we'll get something like which is a acetyl or ester group, hence acetylation took place and CO2H is retained. Okay, obviously O plus H would be there, and then we'll have a water molecule, and the OH minus in the from the water molecule will attack on the H plus and will restore the neutral charge on oxygen. So this compound is known as aspirin. Okay, which is a drug. Okay, so what was the name of this compound? I forgot to tell. This is salicylic. Is it salicylic? No, this is not salicylic. Salicylic would have been when there would be a aldehyde attached to the OH group. This would be salicylic. Okay, now let us look into reaction involving nitrine. Okay, so we'll now look into reactions involving nitrine. Okay, so suppose, so nitrine is basically electron deficient nitrogen, as we also saw carbene in previous lectures. So that is electron deficient carbon, so in this case this is electron deficient nitrogen. Okay, so first we'll be seeing Hoffman bromide reaction. Okay, so in this we'll be seeing suppose we have a amide group. Okay, so amide group on reaction with either Br2 plus KOH, or you can also take KOBr, you can also take Cl2 plus NaOH, you can also take NaOCl, we can also take Cl2 plus calcium hydroxide. Okay, so all these reagents will convert the amide into amine. Okay, so we'll see the reaction as to how this take place. Okay, so mechanism is something like this. So we have RC double bond O NH, and we have this H. I'm just writing it separately, but internally is the same thing. So we have basic medium. What will happen is we'll have negative charge on nitrogen atom and water molecule will be formed, which I am not showing. And we are also passing, I'm talking about the first reagent, Br2 plus KOH. So this will actually act on again Br to form something like this compound, plus Br minus would be formed. Okay, now this compound we can I can also show it as something like an and H here. So now what can happen is, again we have a basic medium which will again take this acidic hydrogen from the nitrogen atom and will get something like this. Okay, now what will happen is, this nitrogen will use its negative charge to form a double bond between itself and the carbon atom, and side by side bromine would be actually leaving this compound as Br minus. So what will happen next is, as this is moving, this actually shows some migratory aptitude and it migrates to the nitrogen bond, or to the nitrogen atom. Okay, aptitude. Okay, so what will happen next is, we'll get the 3-member ring as the intermediate. We have also discussed this in our past set of video lectures on organic chemistry. So we'll get something like this. Okay, so now what will happen is, this is called this intermediate is called isocyanate. Okay, now next what will happen is, we have the basic medium in place. So what will happen is, it will again attack on this carbon atom and we'll get something like OH here, and this N will take back its electron and R would be there. And next what will happen is, this N minus would again attack on the water molecule to capture the H atom from it, and we'll get something like OH, C double bond O, NH and R. Okay, next what will happen is, we will get again OH minus is there in the reaction. So what will happen next is, so OH minus was there in the mixture. So what will happen is, this OH minus will take away the H plus from let me show in different color, this H plus from the acid group here. So what will be the thing, we'll get a negative charge here and NHR is present here. Next what will happen is, the negative charge oxygen atom will form the double bond between with the carbon atom, and it will this group will evolve as a CO2 gas from this compound, forming a N minus HR plus CO2. N minus HR will again attack on water molecule to form NH2 or RNH2. Okay, so amine is hence formed from amide using Br2 in basic medium. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples on the same. So till then, good luck and goodbye.